We know by now that REST is not a standard, but it does use standards. Status codes and when to use them are part of the HTTP standard. It's really important to get these right because these status codes are the only thing a consumer of the API, like a client side web app, can inspect to know if a request worked out as expected and, in such a case, how it worked out. And if something went wrong, whether it's the fault of the consumer or the fault of the API itself. We are currently returning 200 OK status codes. But if we keep on sending back 200 OK status codes for each and every request, the consumer of the API would assume the request worked out as expected, even if it went wrong. So it's important to be as specific as possible. And remember that consumers of the API are typically not humans. All these consumers can inspect reliably is that status code. They can't just read out and interpret error messages. From time to time, problems arise. Something goes wrong. If we only send back a 500 internal server error in all those cases, the consumer would never know if it's their fault something went wrong. For example, trying to get an author that doesn't exist is a client mistake. And that also means that the client or consumer can correct it and try the request again. Other times, it's the server's responsibility. For example, the database is unavailable. The consumer of the API cannot correct this because the mistake wasn't made by the consumer. Alright, so what are these status codes then? There's quite a few, and an API does not necessarily have to support all of them. But let's look into a few common ones. There's 5 levels of status codes. Level 100 status codes are informational. These weren't even part of the HTTP 1.0 standard. They are rarely used by APIs. Level 200 status codes mean the request went well. The most common ones are a 200 OK for the successful GET request, a 201 created for the successful request that resulted in the creation of a new resource, and a 204 no content for a successful request that didn't return anything, like a successful delete request. Level 300 status codes are used for redirection. For example, to tell a search engine a page has permanently moved. Most APIs don't have a need for these either. Then there's the status codes that signify that the consumer did something wrong. These are level 400 status codes signifying client mistakes. 400 means bad request. The request you, as a consumer of the API, sent to the server is wrong. For example, the JSON the consumer provided cannot be parsed. 401 unauthorized means that no or invalid authentication details were provided. 403 forbidden means that the authentication succeeded, but the authenticated request still doesn't have access to the requested resource. 404 not found means that the requested resource does not exist. And then there's 405 method not allowed. This happens when you try to send a request to a resource with an HTTP method that is not allowed. For example, were we to try sending a post request to API/authors/the author ID when only GET, for example, would be implemented on that resource, we would get this back. Then there's 406 not acceptable. Now we're diving into representation media types. This means that the consumer of the API requested a representation format that is not supported by the API, and the API doesn't supply a default representation. For example, a consumer might request the application XML media type, while the API only supports application JSON and does not provide that as default representation. 409 conflict means that there's a conflict with the request versus the current state of the resource the request is in. It's often used when you're trying to edit a version of a resource that's been renewed since you started editing it. 415 unsupported media type is the other way around from the 406 status code. Sometimes we have to provide data to our API in the request body, when creating a resource, for example. That data also has a specific media type, and if the API does not support this, a 415 unsupported media type code should be returned. Lastly, there's 422, unprocessable entity. This is part of the WebDAV HTTP extension standard, so it wasn't part of the original HTTP standard. It means that the server understands the content type of the request and the syntax of the request entity is correct, but it was unable to process the contained instructions. This is typically used for semantic mistakes, and semantic mistakes, that's what we get when working with validation. So if a validation rule fails, a 422 is what is returned. Interesting fact, in June 2022, a new HTTP semantics standard was published. You're looking at that right now. Everything you've just seen on the slides is based on this official standards document, except for one of the codes, 422. It wasn't part of the original HTTP semantics standard, but as it's such a good fit for validation errors, it is now. So, a 422 is now officially part of the HTTP semantics document, but they did rename it. It's now named unprocessable content instead of unprocessable entity. Seeing it is still early days, it will probably take a bit of time for frameworks like ASP.NET Core to adopt this, but chances are pretty good it will happen in the upcoming years. And lastly, there's level 500, server mistakes. 500 internal servers should definitely be supported. This means that the server made a mistake and the client cannot do anything about it other than trying again later. That's a lot of status codes. No reason to learn them by head. We will look into them when we encounter them. Let's fix the mistakes that are in our code at the moment.